Uh, can you repeat U10? What is U10, U9? I'm not getting what it is.
U10 is group, and so as U3 and U12. All
What is
three are in group.
U3? What is U3? What is U12? Which kind of group is this?
Group means
Which kind of elements they are having?
sir, they are having all the elements, which come in that bracket. Like for U10,
So
No. UN is the
it
group.
is
okay,
different.
okay.
UN is a set of all positive integer less than n. So whatever I have n less than n, which is relatively prime to n. Okay. So
I thought you
whatever
were asking this U3 and
elements,
U10,
yeah, yeah,
U12.
yeah. So U3 is nothing but all the elements. U3 contains all the elements which are relatively prime to 3. Okay, so 1 is always there, always there. Okay, and then 2, because 3 is not there. Why? What is relatively prime? Relatively prime means two numbers are said to be relatively prime if they have common factor only 1. 1 is the common factor in that two. Okay, not any other common factor other than 1. U10, it contains 1, 3, U12. So these all are the group. Can someone tell me what is, I erased that one. What is identity in U3? What is identity element in U3?
So 1.
1 is nothing but the identity. Very good. What is inverse of 1? The inverse of 1 is nothing but, what is the inverse of 2?
It will come
2.
2. 2 into 2, because it is 2 into 2, 4, and 4 is nothing but 1. Correct. Inverse of
yes
2 is nothing but itself.
2.
So, what about here? What is identity?
1 only.
1
yes
only.
1.
Here I have A, here I have A inverse. So, what is inverse of 1? Inverse of 1 is 1. What is the inverse
1
of 3?
7.
7.
7 is the inverse, okay? Because 7 3s are 20, 7 3s are 21, and 21 mod 10. You are getting 1. Correct. Absolutely. Identity. What is the inverse of 7?
3.
3. Okay. What is the inverse of 9?
9.
9 only. 9 into 9, 81.
81.
Correct. Very good. Very good. Very nice. I'm good. 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 So this is what you can easily find for U12 or any group, or it is called as a group. UN is nothing but the group set of all positive integers less than n having relatively prime. Now you have finite group also, you have infinite group also. Okay.
Yes.
Infinite group is nothing but the natural number with addition. Yes or no?
Yes.
This group, how you can say yes? Natural number with addition. What is identity element? Natural number with addition is this a
0.
group? 0 is not belongs to natural number.
No, sir. It's the identity element.
So it is not a group. Natural number with addition is not a group because identity element is not there. Yes or no? But natural number into product is a group. Why? Whether it is a group, natural number into product.
Yes, sir.
Yes, sir.
It is group. Tell me the inverse of 1 then. When I talked about the product, natural number into product is a group or not? You are saying yes, it is group. Tell me the inverse of 1 then. Are you getting now what is meant by group? Tell me what is the definition of group?
So it should satisfy all of the 4 conditions.
Which of that 4 conditions?
It should be closed, then
Very
associate,
good. Very good.
in identity element, and then inverse.
Yes, but you can see natural number is again not a group.
Yeah.
Why it is not? Inverse with
Uh,
product is also not a group, and with
with addition also it's not a group.
it is not, because here identity element not exist and here inverse element is not exist. Okay, not a group. Every other person got it, no? What I'm trying to say.
Yes, sir.
Okay. Now tell me what is real number with dot is a group? Just do the calculation in your mind.
No, sir, it is not a group because
Why?
the inverse condition doesn't get satisfied
For which element?
for A
0.
is
Yes,
0, yes,
for
0,
zero. For zero is that element. So it is
and
not a group.
and the rest 3 are getting satisfied.
Yes. And what about R star dot?
Yes, it's a group.
It is.
It
It's a
is a
group.
group.
R plus,
It is a group.
It is a
yes,
group.
it is a group. Okay. So you can now you can see every property is important here. Every property is important. Okay. These are the
Sir,
examples. Yes.
R minus is not a group, right?
No. R minus is also why it is not a group. R minus is also a group. Why it is not? Why you think?
So associative property.
Associative property. Yeah, correct. Absolutely correct. It is
So
not a group.
minus, if there
Yeah.
is a minus, it's never a group because
Yes.
associative
That minus is itself sometimes not satisfying associativity. Very good. So you can define in that way. These all are the examples of infinite group. Okay. Can someone tell me finite group? Any example of finite group? Yes, U12. No problem. It is good. With product. Huh? With product. Yes or no?
Yes, sir.
It is good. Someone saying, sir, Z4 plus Z4 plus means what? When I talked about Z4, that plus is also denoted by sometimes it is mod 4. Huh? Mod 4. It means when I talked about 5, 5 is nothing but again 0. Got it? This Z4 contains how many elements? 0, 1, 2, 3. That 4 again 0, 5, it's reminder. This is with respect to plus, it is group. Okay. With respect to plus, it is group. Yes or no? So these are some examples. Okay. Now in today's lecture, we are going to see what is subgroup. What is the condition for the subgroup? So write down everyone. Subgroup.
Sir, can you show the previous slide for 1 second? I was writing.
So this is example. This is some of the examples. You can find out.
So, sir, can you please explain the third one again?
Third one is R dot. This one, no?
Yes,
R
sir.
star comma R star is nothing but what? Non-zero elements with respect to product. So 0 is not here. When R dot here 0 is there, but here 0 is not there. So dot is nothing but normal our multiplication. It is closed. It is associative. Identity element is equal to 1, and you can inverse of A is nothing but 1 upon A is the inverse.
Yes, sir. Thank you, sir.
Okay. We don't have that much of time to spend on the group now. Okay. I think everyone got this. What is group and everything. Okay. Can someone tell me what is the definition of the subgroup? What do you think? What will be the definition of subgroup? Okay. So let's write down the definition first. Then we will think. Subgroup. So let G be a group. When I talked about G be a group means what? G satisfy all that four conditions. When G be a group and let H be any non-empty subset of G. So we have one subset of G which is non-empty. Then H G be a group, or I can rewrite that one for your betterment. Let G with some binary operation be a group. So this is nothing but my binary operation. Everyone understand now? I define the binary operation. Yes or no?
Yes, sir.
That binary operation may be plus, maybe minus, or anything. Okay. Okay. So G, where we are, where we are. Let G some binary operation be a group. So this is binary operation on G. Okay, this is binary operation on G. And let H be any non-empty subset of G. It's called as subgroup if is called as subgroup, is called as subgroup of G if H with that same binary operation is group. So got it, everyone? When H becomes subgroup, the first condition, it should firstly subset of G. Okay, so whatever the elements we have in G, we should have same element in the H itself. Okay, and also with the same binary operation, see whatever the binary operation I have here, with the same binary operation, that H together with that binary operation should form a group. For example, tell me real number, I can say star, comma, I can take here dot, whether it is group.
Yes.
It is a group. What is identity element here? 1. Okay. Now tell me Z with Z star is subgroup. Whether it is subgroup. Whatever that product is the same operation.
Yes, sir.
It is. Why? Because it itself a group first and R stars. So you can write down here as Z star Z star is a subset of R star and Z star dot is group itself. So this implies Z star comma dot is subgroup. Please write down this one. So we'll take some examples and we will take, one important remark also, theorem, how to check whether it is group or not. We have one important thing. Tell me then. Write down. Yes, you are not.
Star, Z star and multiplication a group because for
Here.
inverse
No. Oh.
inverse is not satisfied.
Yes, it is not a group. Even if it is a subset. Yes, correct. So it is not correct. I'm so sorry. I'm thinking in a different way. So correct. Here it is a subgroup or not? The answer is no. The answer is no. Why no? Even if Z star is a subset of R and Z star is not a group. Correct. Why? Because inverse does not exist. Correct. So it's not subgroup of this. Okay, very good. Good observation. Now, can someone tell me, can example of group and subgroup? Example of group and subgroup, yes, anyone? Anyone? Example of group and subgroup. Am I audible?
Yes, sir.
So you can take no simple one. You can take a natural number, not natural number. We can take a Z, not plus here. Z together with plus. Z comma plus. Whether it is a group. Whether it is a group.
Yes, sir.
Yes, sir.
Because identity element is 0 and inverse is nothing but its negative number.
Negative.
Okay. So both the elements belong to Z, so it is a group. Now the set of even numbers with plus set of even numbers. So we can define set of even numbers is nothing but 2Z and plus. Whether is a group. Whether it is a group. Check it out now. Closed one is there, no problem. Associative is there, no problem. What is identity here?
0 only.
0 only identity. 0 only. 2Z is nothing but the 0. So identity element is 0. And what about inverse of each element? Whether inverse of each element exists here?
Yes, sir.
Sir,
Thank you
yes,
so much.
sir.
Yes. So it is group. Now understand. So this is also a group and 2Z is a subset of Z. Yes or no? Every element of 2Z belongs to Z. This implies set of even number with plus is group. And itself 2Z plus is subgroup also. So see, we have two examples. Even if we have a subset, but it is not a common group, so it is not a subgroup. But here it is subgroup. Got it now? Because it is itself a group with the same binary operation. So here we have plus operation, here also we have plus operation with the same binary operation. Okay, got it? Now everyone clean and clear about this concept subgroup? Yes or no?
Yes, sir.
Okay, okay. Now write down some remark. Then we will see more example. So in remark, let G be a group. Let G be a group and H is a non-empty subset of G. Okay, G be a group and H be a non-empty subset of G. If whenever A and B belongs to H, then AB inverse also belongs to H, then H is a group. Okay, but when product operation is there, when product operation, you can write down here when is binary operation. Got it? So no need to check for all the properties. What you need to check you just need to check if you take whenever two elements, any two elements from H, you can take it and just find out whether A into B inverse also is a part of G or not, H or not. That's it. So take any two elements from H and find out just A into B inverse, whether it is belongs to H or not. The first condition is what? But H be a non-empty subset of underline this. Everyone got this? And for additive one, same, let G be a group and H is a non-empty subset. If for all, you can write down for all A and B belongs to H, we have A minus B also belongs to H, then H is subgroup. H is subgroup of G. Write down that two remarks. So no need to check whether H is a group or not. Just need to check two conditions. Okay, what are the two conditions? The first condition is it is subset or not. H is a non-empty subset or not. And second condition, whether A minus B or A into its inverse is a part of H or not. That's it. Okay, can I give you one example? Are you done with that? Yes or no?
Yes, sir.
Okay. Okay. So, example. So I have given G is equal to group G is nothing but Q star with dot, and my H is nothing but 3 into Q star comma dot. Tell me whether it is group or not. Tell me it is group or not. It's subgroup or not. Check. H is subgroup of G. Yes or no? Tell me now what we are going to see. So the first thing you need to check what kind of elements we have in H. Okay. So let some A and B belongs to Q star. Then tell me what kind of element we have in H. Yes or no? Am I audible clearly?
Yes, sir.
Yes, sir.
Okay. So if A and B belongs to Q star, we have 3 Q star. So it's just a multiple of 3. So 3 and 3B belongs to 3 Q star. So tell me whether 3 Q star is a subset of Q star. Yes or no?
Yes.
It is clearly because Q star, 3 Q star, C is always a subset. Clearly. So my first condition is satisfied. So what is my second condition? You need to find out it is product because they have given product. No. So what we need to find out? Take any two elements. Take any two elements from H. H is nothing but what I have H here, 3 Q star, and we need to show that A into B inverse also belongs to H. That is what we wanted to show that. So let's check it out. So let 3a comma 3b belongs to 3q star. Now, what is 3a into what is its inverse? 3b inverse. So we need to check what is the inverse of 3b. So what is identity here? So
One.
here, yes, here 1 which is nothing but e, which is nothing but belongs to q star. Okay, and keep one thing in your mind. Whatever you have identity element, whatever the identity element you have for the group, the same identity is for the subgroup. Okay, the same identity is for the subgroup. So you can write down E is equal to 1, which is also belongs to E, whether E belongs to yes, correct. That is my first point. Whether E belongs to here, what is identity here? 3q star. What is identity in 3q star? Tell me now. What is identity element here?
1 only, no?
What whether 1 belongs to 3q star? That is what my point. 1 is the correct answer. My point is whether 1 belongs to 3q star.
Yes, sir. Yes, sir, it does.
How?
1 by 3. 1 by 3
Correct.
belongs to q star.
Yes, because 1 by 3 belongs to q star. So 1 by 3 get cancel 1. So can I write down 1 now? Everyone understand now that? So 1 also belongs to 3q star, and we called as that 1 is nothing but the identity. Okay. So then inverse of 3b is equal. What is the inverse of 3b? Is, can someone tell me? 1 upon 3b. Okay. 1 upon 3b is the inverse. So now what I want, a into b inverse. So what is a here? 3a and 3b. So it's inverse. So a is nothing but what? 3a into the inverse of 3b. What is the inverse of 3b?
1 by 3b.
1 divided by 3b. So that get cancelled. What you remaining with? A divided by b. Whether a divided by b belongs to 3q star. That is my question.
No, sir.
Hmm? As so this is my question now. So we need to find out this. Okay. So let a and b belongs to q star. Yes or no? So can I write down? This is a into b inverse also belongs to q star. Can I say that? Why? Because if it belongs to q star and q star is a group, so its inverse is also there. Yes or no? As B inverse exists in Q star. So that is B inverse. I can say like that. Okay. So this implies, can I say that 3 into A into B inverse also belongs to Q star? So 3A into 3B inverse also belongs to Q star. Because any number if you multiply, it's also always a part of Q star, Q star, Q star. Okay. So finally, what you are getting, this 3a into 3b belongs to q star, but I want in 3q star. So whether 3a into 3b inverse belongs to 3q star as per the definition. Yes or no? Yes or no?
Yes, sir.
Okay. So again, can I say that a into b inverse belongs to 3q star?
Yes, sir.
So this implies a divided by b also belongs to 3q star. Got it? So
Sir, can you tell the last part?
This one or this one
Yeah,
you're talking about?
A divided by B belongs to 3Q star.
It's B inverse. I just write down 1 upon B. No.
Okay, okay.
That's it. B
And
inverse
what
I can
about
write.
second last A into B
Okay.
inverse belongs to?
You understand up to this? Okay.
Yes.
So I can take, if I divided by that, it belongs to 3 star, 3Q star. If I divided by 3 to that number, what I'm getting? It's product. It's product. It's product. If divided by 6. So divided by 6 means what? Divide by 9, sorry, 3 into 3. So that get cancelled. And A into B star
Okay.
also belongs to 3Q star. See
Okay.
what happened here. Any number, you can take any number from Q star, which is also belongs to 3Q star. Because that Q belongs to P divided by Q, any number, P divided by Q. If I say whether A belongs to 3Q star, you can say definitely yes. Why? Because A divided by 3, you can write down the value of A is nothing but 6 divided by 3. You can take any value. Value of A is nothing but 6. What is 6 divided by 3?
2.
2. But 2 is not belongs to here. So you can write down again 2, or instead of divided by 3, I divide by 2.
Okay.
I divide by 2. So I will get 3 into. So I will get 3 here. And 3 belongs to 3Q star. Okay. So it's
So what is
trivial
that? 3
example.
belongs to 3Q star.
Yeah. 3Q
Okay.
star means what? What is 3Q star? So 3Q star is a set having 3 into P divided by Q, such that P and Q belongs to Z. Z star, because not 0 is there. Like that. This is the set.
Okay.
So we should have a 3 into any PQ. You are able to write down that number A divided by B is equal to 3 into AB. So you can give me any number. You can give me any number, any division, A divided by B. I can write down that A divided by B in the form of this. Give me any number. Someone is saying, sir, 7 divided by 3. So you can write down 3 into 7 divided by 9. Am I correct?
Yes.
And which is belongs to 3Q star. Are you getting what I'm trying to say? So when we have A divided by B, you can also write down. You have another way to write down like that. That 3 into A divided by 3B belongs to 3Q star.
Okay, we just wrote in it is same, but we wrote it in a different way.
So this is what we can write down like that way, or you can write down in that way also.
It's one and the same.
One of the same thing. So my point, whether A divided by B belongs to 3AQ? Yes. Why? Because you can write down 3 into A divided by 3B. That is belongs to 3Q star.
Okay.
That's it. So what I am getting, what I started with here, we have started with this. A and B belongs to 3Q star, and I am getting this A into B inverse. A into B inverse also belongs to 3Q star. What it means? It is a first condition. If we have A and B belongs to H, and if I find A into B inverse, it also belongs to H, then you are getting G is H is a subgroup of G. So you can write down here in finance. Therefore, 3Q star is subgroup of Q star. Got it?
Yes, sir.
Anyone, any doubts here? Anyone? Any doubts? Write down that.
Sir, which means 3Q star, it belongs to Q star, right?
It is a subgroup means what? Subgroup means what? It is also a subset of Q star, and it is itself a group, whatever the operation we have here dot. So
Okay.
we have, this is also a, in that particular operation 3Q star dot, it is also a group, and it is a subset of Q stars. That's why it is subgroup. So it is a group. Okay. Everyone understand that? Yes or no?
Yes, sir.
Okay. So This is what we have definition of a subgroup, and this is what the theorem. That two are nothing but the theorem. We don't have proof in our syllabus, so just keep that two statement in your mind. These are nothing but what the examples of a group. So let's see for the, can someone tell me any example of subgroup, finite subgroup? Finite subgroup example. Any example anyone can think? For infinite one, it is little bit, Okay, tell me. Just tell me. Suppose let I have r minus singleton 0, comma, I can take dot operation. This is nothing but my group. Or you can simply, we can define r star, no? I can define here r star, comma, dot. Whether it is a group,
Yes, sir.
my h is equal to -1 and 1. So tell me.
Sir, R star comma dot is a group.
Yeah, definitely. So H is subgroup, whether H is subgroup of G. Tell me whether H is subgroup of G. Whether H is subgroup of G. So either you have two options because it is finite group, no. So what you need to check whenever we have a finite group, check whether H is a subset of R or H is a subset of G.
Yes, sir.
So H is a subset of your R star. Yes or no? This is clear. No need to check. Okay. Now what you need to check only whether this is group or not with respect to product. With respect to product, whether it is group or not. So how one can check whether it is group or not? You have another option is there also. A into B inverse. But we have only two elements. For a finite group, you need to draw a table. What is that table? We have dot operation here. We have here -1, 1, here -1, and here 1. Tell me what you will get here. First element,
1,
next,
-1,
next,
-1,
next,
1.
1. So it is closed.
Yes.
Why?
Every element is of
Every operation you do all the necessary combination. So you can write down from table. It is clear that it is a group. It is a closed. What about associative? So we know that dot is associative over R and or R star you can write down, and that H is a subset of R star. This implies dot is associative over H2. Okay. Now, what is identity element?
1,
E is equal to 1. You can see if you multiply 1 into -1, you are getting -1. 1 into 1, you are getting same element. So identity element is 1. Now the inverse. What is inverse? What is inverse?
So for -1, it's -1, And
So
400.
if I A here, we have A inverse. So what element we have? 1 and -1. What is the inverse of 1?
1
1. What is the inverse of -1?
minus 1.
Minus
-1. So whether it is a group
Yes.
with the same operation that we have operation on group H. What is our H is nothing but R star. Okay, so we have here product operation, and here also we just show that here H into that the same operation is group. What is the definition of subgroup? First condition, it should be the subset, and second condition
Should be a group in itself.
with same operation. So it is group. So therefore H is subgroup. Clear and clear? Yes or no?
Yes, sir.
Now next.
Sir,
Yes.
sir, can you show the associative part? What did you say? Right.
See,
Therefore,
see, dot is associative over R star,
yes.
and H is a subset of R star.
Okay.
So it is associative on a big set, and I am taking some element in that.
Hmm.
So definitely this is a associative on H also.
Okay.
Yes or no? See, no. Now, for example, in our class, if 90% students got the 80 plus marks, suppose everyone get the 80% marks. Everyone get the 80% marks. And if I select roll number 5, roll number 10, 15, 20, like that roll numbers, whether that student contains have 80% marks? Definitely.
Yes.
Because everyone is satisfying this one condition. I'm picking some elements, so like that only. No, here H, it is associative over R star, and I'm taking a subset of R star, so definitely it is associative over there. So I just write down that. Okay, got it? Yes or
Yes,
no?
sir. Yes.
I think everyone understand now this concept. Okay, subgroup, is it okay to everyone with the subgroup? It is okay to
Yes.
everyone with the subgroup. Okay.
Yes.
Okay. Okay. So now what we are going to see, subgroup is done, no? So we are going to start with now 1 minus 1 is also done. Any other example? Any other example? Do you realize? Can someone tell me? Third example. Z5 with plus is subgroup of Z with plus. Yes or no? What do you think? What do you think? Just tell me. Yes. Good question. Tell me whether it is subgroup or not.
Sir, I think it is because Z comma plus itself is a group.
Okay. 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 What about this operation? What about if I take 5 and 4, not 5 and 4, suppose 3 and 4 belongs to Z5. What is 3 plus 4?
7.
Whether 7 belongs to Z5?
No.
What is 3 plus 4 in Z5? Z5 we define that plus is nothing but the modulo operation.
2.
Yes, it is 2. Okay. 3 plus 4, it is 2 here. And here if I take 3 comma 4 belongs to Z, and here 3 plus 4, it is 7. Here operation is different. Even if I write down plus plus here, this is like that mod 4. This is different operation. When I talked about Z5, it is operation modulo 5. Are you getting? Are you
Yes.
getting my point? Even if you are saying, sorry, here, but this is not the case here. If this is a group, it is itself a group, it is itself a, but operation is different. So answer is no. Why? Operation is different.
So like in which case it is different because Z5 comma plus and Z comma plus.
No. What you are taking? Here, that plus, it is not that plus. Okay, so I just defined here. No, if I have 3 plus 4 belongs to Z5, if I find out 3 plus 4, so the meaning of here is like that. 3 is congruent to uh, 3, not bigger that element. Suppose I take 7. 7 is congruent to 2 mod 5.
Okay.
Okay, so that plus operation is there. That plus operation is there. Got it?
Yes. Means in both cases that plus sign has a different meaning.
I'm so sorry. I'm so sorry. So everyone understand that now? Why it is not
Yes.
a, because here the operation is different and here it is different. It is not a good. So you
Sir,
may,
could you tell
yes.
once again? I couldn't hear your voice.
Okay, see. Now when I talked about Z5 plus 4, so Z5 is nothing but the modulo group that we have discussed. Z5
Okay.
is the modulo group. What is modulo? Just like that. 7 is congruent to 2 mod n. So that operation is different than that normal plus. Okay. So this is not a group, subgroup. It is itself a group. It is itself a group, but Z5 that plus operation is different. Here I different. Operation is okay. I think now got it.
Okay. Yes.
Operation is different. Just it is itself. Both are the groups. Both are the subset also, but the operations are different. Whatever the operation we are using on Z and whatever the operation we are using on Z plus Z5, these are the different. That's okay. Got it. Now this is what
Yes,
we
sir.
have for the group only. So what we have in the group, we have definition of group, then we have finite group, we have infinite group, then we have subgroups, and the types of subgroup is finite. It means once finite group, then we have a subgroup of a finite group also and infinite group also. Here we have an example. What I wanted to say for infinite group. So this is infinite group. Yes or no? R star dot is an infinite group, but we have subset finite like that. So this is what we have a group. Now let's see for the definition of ring. So we just have definition of ring here. What is meant by ring? So write down the definition of ring. A non-empty set R here I mentioned simple R. When I talked about this R is nothing but the set of real numbers, double line. When I talked about this is stands for ring, R, ring. When group, I just say a G group. Okay, like that only. So G, this is for G, natural number, I write down like that. For integers, I write down this. Natural numbers is double N like that. Then Q is nothing but like that sometimes. But here R is nothing but the set. It is not a natural number. It may be anything. It's called as ring. If binary operation then binary operation, first one is addition. we define addition as a plus, simple plus, and multiplication. So your multiplication we denoted by dot. Here we have two binary operations. First one is addition and second one is multiplication. In group, how many operations we have? In group, how many operation we have? Only one operation. Yes or no? Either it is plus or either it is product. Yes or no? Yes or no?
Yes, sir.
Are you getting what I'm trying to say? And here we have two operations, egg plus also, egg dot also. Multiplication are defined in R. So two operations are defined in that set R, and number one, R is abelian group under addition. Now I will tell you what is meant by abelian group. R is abelian group under addition. Number two, R is semi group. I will tell you what is meant by semi group. Semi group under multiplication. And third one, both left and right distributive law. Now what is meant by distributive? You know that. Law holds in R. That is A into B plus C is equal to A into B plus B into C, and suppose B plus C into A, you can write down BA plus C. Got it now? Okay, everyone knows what is meant by group now. What is
Yes,
meant by
sir.
group? With that four condition. With four condition. So revision. Yes, go ahead.
Closed.
First one is
Closed.
closed. Second one is
Associative.
associative. Okay. Third one is
Identity.
identity. And fourth one is
Inverse.
Inverse.
inverse. Okay. So if suppose any set A satisfies number one closed one and number two associative, then A is called as semi group. Semi-final and final. What is the difference between semi-final and final? The final one is the winner one. So if any group does not have identity and inverse, then such kind of group we called as a semi-group, because if these two conditions are not satisfied, but that two conditions are satisfied, then it is called as a semi-group. Everyone understand semi-group now? Any example? Any example? Whether R plus is semi-group?
Sir, can you repeat once again? If third one and fourth one is not satisfied, then it is called semi-group.
No. That is one of the same thing. No. So I am saying what is satisfied. So if A satisfies the closed one and associative one, then A is called as the semigroup. It means these two conditions are not there. If it is there, no problem. If it is not there, then also it is not problem. I am just checking for whether it is closed or associative. Yes, then it is semigroup. So that's why I gave this example. Whether R plus, it is a group itself. So definitely it is semigroup. Yes or no? Yes or no?
Yes, sir.
Yes.
Clean and clear. No, this is a clean and clear. Whether it is closed, R plus is closed.
Yes.
Yes,
Whether
sir.
it is associative,
Yes, sir.
Yes.
done. Your work is done. It is semigroup. Okay. Now the second one, natural number with addition. Whether it is closed,
Yes.
whether it is associative,
Yes.
so it is closed.
Semigroup.
Semigroup. Whether it has an identity,
No.
whether it is a group,
No.
not a group, but semigroup.
Sir, means for semi-group, only closed and associative property should be satisfied.
Yes, that is what the definition is this. See, A satisfy closed and associative, then A is called semigroup. That's it. That is what the definition is this. And you can write down every group is semigroup. Every group is semigroup. Okay, clean and clear.
Yes, sir.
Okay, and now what is abelian group? So the definition, abelian group. A small a group or capital a group G is called abelian group if for all A and B belongs to G, AB is equal to BA. Commutative law holds. That is, commutative law holds. What is meant by commutative law? What is meant by commutative law? Just check it out. Tell me. What is commutative law? AB is equal to BA. That's it. Okay. Am I audible?
Yes, sir. Yes.
Okay,
Yes,
okay. So it is a group. It means it satisfies 4 conditions of group, and the 5th condition when it's commutative one. Okay. So this is called as a abelian group. Now your homework task. Give me examples of abelian groups. Then in tomorrow's lecture we will discuss about the ring and its properties. Okay. We will stop here then. Please, I request everyone, please put your attendance in chat box. Okay, anyone, any doubts here?
So we have to find examples of abelian groups, right?
Yeah, that is the homework task for you.